Now, though, if we look at our redeem collateral function, which is public right now, we can see as inputs, it takes token collateral address and amount collateral, right? And it is hard coded to message.sender. Our third party user isn't the one with the bad debt, right? We need to redeem a random person's collateral. So what we can do is we can refactor this code so that there's an internal redeem collateral function that can redeem collateral from anybody, right? And only very permissioned functions can call redeem collateral. So what we're going to do is actually we're going to take all of this code and we're going to change it and we're going to delete it and we're going to put it into a different function all the way down to in private and internal functions here. We're going to make a function underscore redeem collateral. And this is going to be an internal function where we can actually redeem collateral from anybody. And as input, this is going to take address token collateral address, same as the regular redeem collateral, also the UNT56 amount collateral, but we're going to add address from and address to. So this way, and this is going to be private. So this way, somebody can liquidate an address from and then get the rewards to. And this is where I'm going to paste all that code we got from above. And I think this looks good. Yeah, we're just going to paste that code exactly like this. Instead of doing message.sender, this is just going to be from and emit collateral redeemed. We're going to update our collateral redeemed to redeemed from. We'll do address redeemed from, address redeemed to. We'll do the token, and then we'll have amount not be indexed. So from, to, token, and amount. So now we got to refactor some of these collaterals. So from, when we do just the regular redeem collateral, we'll update this in a minute, actually. Yeah, we'll update that in a minute. So in this internal function, it's going to be from, to, address, collateral. And then we're going to transfer the tokens to whoever the to is. So this is going to be like the liquidator, amount collateral, and do that. And now we're going to use this internal function up in our regular redeem collateral function that we just created, right? Up here, oh no, up this one. Up here, we're going to dump all this and just use this underscore redeem collateral. And for here, we're just going to say message.sender. So from message.sender to message.sender, token collateral address, amount collateral. And now that we have this internal function, we can use this redeem collateral bit down in our liquidate, which is down here. We can now just say redeem collateral from the user that's being liquidated. So from user to whoever's calling liquidate here. So it's going to be message.sender, the collateral token that we're liquidating, and then finally the total collateral to redeem. So this is why I said we were going to do a little bit of refactoring soon, right? We generally only want to redeem collateral from and to the same person. However, when we're doing a liquidate, we're going to redeem to whoever's calling the liquidate. So they're going to get that reward. The total collateral to redeem is that total amount debt to cover plus some bonus here. And now we actually need to, we need to burn the DSC now. So right now, if we look up burn DSC, we have this public function, which just does the same thing. It just burns from message.sender. We're gonna have to do the same here. We're gonna want to make an internal burn DSC function that allows us to burn from anybody, right? So if we scroll down to where we're doing those private functions, or scroll up, so we have this internal redeem collateral. We also are going to need an internal burn DSC. So function underscore burn DSC, uint 256 amount DSC to burn, address on behalf of, like, whose DSC are we burning for, whose debt are we paying down, and then address DSC from. Where are we getting the DSC from? We have private, and we can go back to the burn DSC, this burn DSC function, right? And same thing, we can just copy all of this, go back to our internal burn DSC function, paste this in here. We're going to want to update this, right? Instead of message.sender, this is going to be on behalf of. We're going to take away their debt. We're still going to do this, but instead of message.sender, it's going to be DSC from, and it's going to be amount DSC to burn. This is still fine. This just needs to be amount DSC to burn. And we don't need to check health factor yet because this is going to be our internal function. So we might even say, like in the comments here, low level internal function, or at dev, low level internal function, do not call unless the function calling it is checking for health factors being broken. So now we have this burn DSC. We can go back up to our burn DSC function. We can just swap, delete all of this, call burn DSC, and this is going to be message.sender amount, right? If somebody calls burn DSC themselves, great. We'll just have them call this burn DSC amount to burn on behalf of themselves, from themselves. Oh, it looks like I got this backwards. Amount should be the first one. Okay. And now we have this burn DSC function. We can go down to liquidate and we can call burn DSC. What are the amount on behalf of from? So the amount is going to be this debt to cover. Amount on behalf of is going to be the user, and the one who's going to be paying this is going to be message.sender, right? Because it's whoever's the liquidator, whoever's calling liquidate is going to be the one who's paying down the debt to cover, right? Paying back that minted DSC. And now, since we're doing these internal calls that don't have checks, we absolutely need to make sure we're checking this health factor is okay, right? So we're going to do uint256 ending user health factor equals underscore health factor of the user. And if the ending health factor is less than or equal to the starting health factor, right? If we didn't improve the health factor, we should revert DSC engine underscore health factor not improved. Copy this, go to the top. We'll do error, DSC engine health factor not improved, go back down. So if we don't improve the health factor, we should 100% revert. And then also, if calling this liquidate function, if paying down some debt and doing all this stuff actually hurts the liquidator's health factor, we should also revert, right? So we should also call revert if health factor is broken for the message.sender, right? If this process ruined their health factor, we shouldn't let them do this, okay? So we're following checks effects interactions here. For the most part, these two functions are making external calls to external contracts, right? And then we're doing kind of like a check afterwards. Again, this is a bit of a trade-off. We could calculate before and then run this, but that's kind of gas inefficient. We're just going to check after we do all this. Hey, just make sure that the health factor is okay. Make sure that we didn't break anyone's health factor. So now we have this liquidation function, which is incredibly powerful and kind of what ties this whole thing together, right? There's an incentive here for people to call liquidate so that our protocol is never insolvent, right? And I know I've been kind of throwing around a lot of these financial terms, but our protocol always has more collateral than it has minted DSC. The value of the collateral should always be more than the minted DSC, always. Incredibly powerful function. We're obviously going to be testing the living hell out of this, right? Because we want to make sure it actually works. Woo! Okay, what do we need now? Oh, well, it looks like we broke some stuff. Oh, this needs a semicolon. What else do we break? There's a little red thing down here. Let's go fix it. Amount. This should be amount DSC to burn. Got a couple more red things. Redeem collateral. User message to sender. Redeem collateral. Oops, we did these backwards. I'm going to copy these. Put these at the front. Okay. Oh, looks like that fixed pretty much most of this. I don't see any more red stuff on the side here. So we're going to go ahead and run forge build. Make sure everything's at least compiling. Awesome. Maybe we'll even run forge test. I don't think this would have broken any tests. Looks like those are working fine. But all right, we're doing some fantastic work. And like I said, at this point, I probably would be running tests with this, but we're almost done with all of our code here. So we're just going to keep going, right? And this code's starting to look pretty darn good, right? We've got these amazing NatSpec comments in here. We've got comments all over the place. Maybe these probably should be cleaned up a little bit, but that's fine. We've got this little dev thing, a shout out saying, hey, don't let anybody call burn DSC without checking the health factor, right? This is really good to tell auditors and security professionals about this, right? It's really good to call this out. we've now have this internal redeem collateral function, so it can be used for the liquidate or the redeem collateral. Health factor, it looks like pretty much all the functions that we originally wrote are working in here, right? And the reason, again, that this all works is because when we mint DSC, we can only mint as much as we have collateral in the system. We're setting this exchange rate essentially for our protocol. Hey, cool, you have $100, you have $150 worth of ETH deposited. Great, you can mint $100 worth of DSC. So it's this exchange rate that we're setting, which is maintaining the price. Let's just double check that we have kind of most of the functions that we want here. And let's also check that they're in the right place. So we go to the top here, got a whole bunch of errors. That's great. Got a whole bunch of constants because we hate magic numbers. We have a mapping of price feeds, a mapping of collateral deposited from user to token to the amount they have deposited. We have their debt or their DSC minted, collateral tokens, the IDSC token. We've got some events in here, a couple modifiers, some functions. We've got a way to deposit collateral and mint DSC in one transaction. We've got a way to calculate health factor. I'm going to tell you right now, there's actually a bug in here. I'm not going to tell you what that bug is yet, though. Maybe you can figure it out. We've got some view functions down below. We're probably going to add more as we write tests, but this is looking pretty darn good. Now, like I said, there's at least one big bug, and there might even be, and there's likely more, but there's at least one big bug in here. So now would be a good time to take a break, because after this, we're going to go deep into writing tests for this protocol. We're going to write some new tests, and we're going to show you some really advanced testing methodologies. So take that break, go for a walk, and I'll see you in a few.